Good morning, friends. We are on page 97, lesson 21 homework. It asks you to fill in the blanks. So right here we have 1/3 times 1. Notice that this 1/3 is the same as this 1/3. And then we have the number 1. And we also have 3/3. Remember that 3/3 is equal to 1, so it's the same. So now they're multiplying. So we have 1 times 3, which is equal to 3, and 3 times 3, which is equal to 9. Next, we have 2/3 times 1. So if you look at it carefully, we have 2/3. Whoa, things are falling. We have 2/3 and 2/3. So we needed something that is equivalent to 1 and also equal to 14 and 21. So 2 times 7 is equal to 14 and 3 times 7 is equal to 21. Okay, for problem C or letter C, we have 5 halves and 5 halves. They're the same and they are multiplying this 1 times 1. So we need to figure out 5 times what is equal to 25. In our case, 5 times 5 is equal to 25. And 2 times 5 is equal to 10. For problem D, they asked you to compare the first factor to the value of the product. So remember, the product means the answer to a multiplication problem. So they're asking you to compare the first factor to the value of the product. So they want you to look at the factor that they have given you here and to compare it with the equal or the answer, right? So if you look at it, the first factor is equal to the product. They are the same because it was multiplied by 1 each time. Anything multiplied by 1 always equals to itself. So we have 1 right here, 1 right here, and 1 right here. And 3 divided by 3 is equal to 1. 7 divided by 7 is equal to 1. 5 divided by 5 is equal to 1. That's what they're asking you to look at and to compare. So, number 2, they're asking you to express each fraction as an equivalent decimal. Remember that the word equivalent means equal. So they're looking for an equal decimal. The first one is partially done for you. So all you're doing is filling out the answer. 3 times 25 is 75. Think about quarters. If you have 3 quarters, that's equal to 75 cents. That's where I'm getting 75 from. Now, 75 hundredths. That means that your 5 needs to be in the hundreds place. So everything else is going to follow after that. So 5 is in the hundreds, then that means 7 is in the tenths, your decimal, and your ones. So you get 0.75 or 75 hundredths, exactly like how it's said. Problem B, you're multiplying 1 times 25, which is equal to 25. You know what? I am going to make sure I highlight this so that you can see it more clearly, because I think that the colors are going to help you because of the color coding. So they personally help me because sometimes math can be a little confusing and the colors help me see where things are supposed to be. So notice that that 5 is in the hundreds place, and that's why it's in the hundreds place. Okay. So for problem, were we on B? Yes. 1 times 25 is equal to 25, and 4 times 25 is equal to 100. Remember that 4 quarters is equal to $1. That's what I'm thinking when I see 25s. So I have 25 hundredths. So that means your last digit has to be in the hundreds place. So this 5 is in the hundreds place. Then that means that the 2 is in the tenths place, and the 0 is in the ones place, and there's a decimal in between. So we get 25 hundredths. For problem C, I am multiplying 2 times 2 because I either want to get tenths or hundreds. In this case, tenths is closer. 2 times 2 is equal to 4, and 5 times 2 is equal to 10. So we have 4 tenths. To write that as a decimal, it is going to be 4 tenths. The 4 is in the tenths place. That means your decimal and your ones are after it. So I am going to highlight what I multiplied here so you can see that a little better. Over here we have 3/5 times 2 over 2. I'm multiplying 2 over 2 because I want to get tenths, because that's a decimal place that's close. So we have 3 times 2, which is equal to 6. And we also have 5 times 2, which is equal to 10. So we get 6 times. The 6 is in the tens place, and that's where you see your 6 in the tens place, and the other numbers follow through. Next, we have 3/20 times 5/5. So what I'm going to do is I'm going to multiply 3 times 5, which is equal to 15, and 20 times 5, which is equal to 100. So right here we have 15 hundredths. The 5 is going to go in the hundreds place, your 1 is going to go in the tens place, and your 0 is going to go in the ones place, okay? Next, we have for F, we have 25 times 5. We're multiplying 20 times 5 because we either want to get 10 or 100. And in this case, 20 is already too big for 10, so we're aiming for 100. So I'm multiplying 20 times 5, which is equal to 100, and 25 times 5, which is equal to 125. So I get 125 hundredths. Again, it says hundredths in your denominator. So your last digit, which is your 5, should be in the hundreds place. And then your 2 in the tens place. And then your 1 in the ones place. Okay? Don't forget that decimal or else your answer is incorrect. Turning to the next page, page 98, you're doing pretty much the same thing. So we have here, we're multiplying 23 times 4, which is going to give us 92, and then we're multiplying 25 times 4 because we want to get 100 in order to put our place value in the hundreds place. So we have 92 hundredths, that means your 2 is in the hundreds place, your 9 is in the tens place, and your 0 is in the ones place. For problem H, we have 89 times 2 because we want to multiply 50 times 2 to get 100. So what you do on the bottom, you must do to the top. So right here we have 89 times 2, which is equal to 178, and 50 times 2, which is equal to 100. So we get 178 hundredths. That means that your last digit, the 8, needs to be in the hundreds place, your 7 will be in the tens place, and your ones will be in the ones place. For the next problem, problem I, we have 3 and 11 25ths. So again, we want to change 25, the denominator, into 100. To get to 100 or dollar, right, you have to multiply times 4. So what I did here was multiply 25 times 4, which gives you 100. And we have 11 times 4, which is equal to 44. So the whole number, you leave it alone. So what you have here is 3 and 44 hundredths. 3 and 44 hundredths, 4 is in the hundredths place. The other 4 is in the tens place. And your 3 is in the ones place. For J, you have 50 as your denominator. You're going to multiply times 2 to get 100 because you want your denominator either to be in the tens, hundreds, or thousands. Thousands would be kind of stretching it, so we're not going to use thousands. So we're going to multiply right here, and we get 100. Oh, sorry. I was looking at another one. So what we get right here is we're multiplying 41 times 2, which is given to you as 82. And when you multiply 50 times 2, you're going to get 100. So we get 82 hundredths, so we're running down 82 hundredths. And the 5 is in the wholes place, so it is a whole number 5 that goes in the ones. So 2 is in the hundredths place. Excuse me, sorry. 8 is in the tens place, and 5 is in the ones place. Now, problem 3, we have 6/8 is equivalent. Remember, the word equivalent means equal to 3/4. How can you use this to help you write 6/8 as a decimal? Show your thinking to solve. So if I had 6/8, what I would do, or 3/4, what I would do is I would multiply to get 100 because I want to put it in the hundreds place. So your 5 is going to be in the hundreds place. So I can write it as a decimal. So what I did first was I multiplied 3 times 25, which is equal to 75, and 4 times 25, which is equal to 100. So it is easier to multiply by 4 to get 100 than to multiply by 8 to get 100. Next, I have 10 ones times 7/5. What I'm going to do is I am going to multiply. A number multiplied by a fraction is not always smaller than the original number. Explain this and give us at least 2 examples to support your thinking. So that means that your answers might not be the same as mine because you might have another original number that you chose. So I chose 10 times 7/5. 10 times 7 is going to give me 70. And 1 times 5 is going to give you 5. So we have 70 divided by 5. 5 can go into 7 one time. 7 minus 5 is 2. Bring down your 0. 5 can go into 24 times. 20 minus 20 is equal to 0. So we have 14. So 14 is my final answer. Over here, I have 9 times 4 thirds. So I'm multiplying 9 times 4. 9 times 4 is going to give you 36. And 1 times 3 is going to give you 3. So what we have here is we're dividing. How many times can 3 go into 36? Wait, why did I say 12? Oh, well, I see why. They divided this by 3, or by 3, yes. So we get 3 divided by 12, which is going to give us 4 as our final answer. I'm actually still confused where we got 3 and 12. So if we divide 36 divided by 3, we would get 12. And if we divide 3 divided by 3, we would get 1. So your final answer should actually be 12. I'm not exactly sure why I wrote my other number. It's equal to 12. Okay. Number 5. Elise has 3/4 of a dollar. She buys a stamp that costs 44 cents. Change both numbers into decimals and tell how much money Elise has after paying for the stamp. So we know that 3/4 is the number she had, and we want to change it into a decimal to see how many cents she has. To do that, I'm going to multiply times 25 because 4 times 25 is equal to 100. So we have 4 times 25, which is equal to 100, and we have 3 times 25, which is equal to 75. What you multiply in the bottom, you have to multiply in the top, so that's why we did that. So we get 75 hundredths. The 5 is going to be in the hundreds place, as you can see. And then we also need to change 44 cents into a decimal, which is written like this. So what we're going to do is we're going to subtract 75 minus 44. 5 minus 4 is 1, 7 minus 4 is 3. Bring down your decimal and your 0, and your answer is $0.31. So Elise will have 31 cents after paying for her stamp. And I believe that is all for today. So I will see you tomorrow. Let me know if you have any questions in class.